342. C of x 0.002 x cubed plus 0.1 x squared plus 42x plus 300. Okay, and this is the cost. In it says hundreds of dollars. I have to make a note so I do not forget. Hundreds of dollars, okay, of producing x securities. So x is units. And currently 40 units are produced daily. What is the current daily cost? Okay, so what do? We're asked to determine the daily cost if we produce 40 units.
Find the derivative.
Careful, it says the cost. It doesn't say the rate of change of the cost. It doesn't say the marginal cost. It says the cost.
Do you plug in 40 where
That's
x
it.
is?
That's it. Very good. I'm going to share my screen. In y equals. Let me see. I think I worked in Seek. No, I didn't. Not with this calculator. Okay, good. So in y equals, we have 0.002 x to the third, and then plus 0.1 x squared, and then plus 42x, and then plus 300. And yes, you can say, why are you plugging it in like that if you only have to plug in 40? It's easier for me. Who knows? I may have to come back and do something else. Okay, so it's hundreds. So how do I write it? Dollars, 2268, and then how many zeros?
0, 0.
Exactly. That's it.
2.
Yep. Awesome. Back to the problem. Part B. What is the marginal cost when x is 40? Ah, that's different. So marginal cost. Now it's a different question. So what do I do first for the marginal cost?
Is it now you find the derivative?
Excellent. Now I find the derivative. Can anyone help with the derivative? Anyone?
Is it 0.006x squared plus 0.2x plus 42?
Brilliant. We're asked to find the marginal cost when we produce 40 units. What do I do now?
Plugs 40 in x.
Yes, in C prime. Good. So I'm going to create my next function, which is 0.06x squared, and then plus 0.2x, and plus 42. Because I don't have to plug in anything. It's already in there. So that's why I do it like that. Good. So remember, it's hundreds. So what do I write? C prime
5960
is 5960 measurement unit. So here we put dollars. This always has a totally different measurement unit. It cannot have the same measurement unit. This is the rate of change. Which is a ratio. And this is a cost, which is not a ratio. So what is this?
Dollars per unit.
Thank you very much. Awesome. Thank you. Good. Moving on. Where is my problem here? Okay. Use the result from part B to estimate the daily cost of increasing production to 42 security systems daily. Okay. So So in part C, my page 4. So we no longer want to produce 40 per day, but we want to produce 42 per day. Okay. Good. X was 40. But now we want 42. Can anyone identify dx for us?
Is it just 2?
Exactly. Okay, we already have f of x, which in our case is c of x. I can copy it. So we have all the information here. Okay. Good. We already have c prime. I can create it again. And we have dx. That's all we need to do. We have the function with f, we have f prime, we have dx, which is 2, we have x, which is 40. So all we are asked to find is to write this formula. C of 42, 40 plus 2, is approximately C of 40 plus C prime of 40 times 2. So we are approximating the cost. This is not exact. This is an approximation. So we are asked to approximate the cost if we decide all of a sudden to move from 40 units per day to 42 units per day. All we have to identify is delta dx, which is 2, because 40 plus 2 is 40 plus 2 is 42. F of x is still f of 40. F prime of x is still f prime of 40. And now dx is 2. We calculate this, and we have the approximation of the cost if we want to manufacture 42 units per day. So I copy. Now I can write the equal symbol because I'm writing it for this. I have C of 40, 226, 800. I have C prime of 40, 5960. And I have times 2. And that is the approximate cost if we decide one day not to produce 40 units per day, but 42. What if I want to produce 41? What changes here?
We're just changing 2 at the end to 1.
Exactly. So this changes into 41, and this changes into 1, and this will be 1. Careful now, I don't want to be too far away from 42, but what if I want to produce 38? Careful, what will delta dx be?
That will be -2.
-2. What if all of a sudden I want to produce 45? Again, the error will be a little bit bigger probably because I am 5 units away from 40, and I want to be close. But what will change in this whole thing with 45? This will be 5, and this will be 5. And that's it. Now let's calculate this. So we have 226,800 plus 5960 times 2. And we get 238,720. 238,720. And a measurement unit, please.
Is it dollars?
Yes. Perfect. Okay, where is it? What will be the actual additional daily cost of increasing production to 42? What is the actual? Actual. See what it said here? Estimate. In other words, approximate. But here it says the actual additional daily cost. Okay. So here we are asked to find delta C, which is C of 42 minus C of 40. Because it says actual. And the formula for actual is F C of 42 minus C of 40. That's the actual. This is the approximate. Good. So see, that's why I have the function plugged in. I go back. All I have to do is plug in 42. It doesn't do it because I'm not where I should be. Okay, now it does it. 42. So it's this minus this. That's the actual. So at 42, we have 238,857.6 because it's hundreds. And this one was minus 2268 and 2 zeros. Oh, I didn't mean to do that. I meant to do this. So 238,857.6 minus 226,800. So that's it. 12057.6 in dollars, of course. That is all about differentials that we really need. The function may be different, the setup may be different, but that's it. Any questions for me, please?
Could we do one more of them?
Absolutely, yes. The answer is always yes. Okay. Let me see how am I on time. Okay, perfect time there. Okay.
Excuse me.
Yes, ready?
I had to get out of my chair for a second, but I missed the part where you went to the final answer. It was 238,857.6 minus 226,800.
Yes, let's do that.
Where did you get?
Yes.
Where did you get the C of 42 from? Because on my paper it was 238,720. I just want to know the.
Careful. Yes, let's explain this again. In part C, we were asked to estimate. So we're estimating with the formula.
Gotcha.
C of 40 plus F prime, C prime of 40 times 2. In part D, they say find the actual. Okay, so this is the estimate, this piece is the estimate, and this is the actual. This is this piece, just this piece is the estimate, error, and this is the actual error. How do I determine the actual error? The actual error is F of 42, C of 42 minus C of 40. C of 42 minus C of 40. You saw how we plugged this in, right?
Yes, correct.
And then we subtracted them. Now, if you want to compare, then we should compare these two. They have to be close. So let's do that. Let's multiply. So 0, 2, and 1, 18, 9, and 1, and that's 10, 11. So this is the approximate error, so to speak, additional cost. This is the actual, if we are using the function, not the derivative. But this is quite close. 11,920 and 12,057, they're quite close. So if your boss says, give me an estimate quickly, you're not going to do this. You're going to do this. And you say it's an estimate, sir, ma'am. Okay? But if we want the actual cost increase, if we want to stop manufacturing 40 per day and we want to go to 42 per day, this is the additional cost. The exact. But this is the approximate.
I got it. Thank you.
Perfect. So we want to go and look at another one. Very good idea. Okay, so what about the marginal revenue? Okay, I'm on page 5. So, determines the daily revenue in dollars. So this is dollars and X units. Okay, 29 on the same page for 342. Okay, so we have R of X equals 0.005 X cubed plus 0.01 X squared plus 0.5 X. Okay, currently they are manufacturing 70 units. In part A, what is the current daily revenue? What do we do for 70 units?
Just substitute it in.
Yes, R of 70. And since you know we're going to get there, let's continue and we're going to put them in a minute. Okay, obviously, what is the marginal revenue when 70 units are sold, produced and sold? So what do I need to do to find the marginal revenue now?
The derivative.
Good. So let's see. 0.015 x squared plus 0.02x plus 0.5. Good. And R prime of 70. So I'm going to plug them both in the graphing calculator. Go back to y equals clear and clear. And let's see. 0.0. You're going to love this problem, because I'm sure you understood what's happening here. Good, and plus. So now you see why I like to see the function and make sure that it's entered correctly, and I don't have to worry about it. 0.015 x squared, and then plus 0.02x, and plus 0.5. And then I want to plug in 70. And I get both answers right away. Boom. So 1799, and you'll give me the measurement unit, and 75.4, and you'll give me the measurement unit.
The first one is dollars and the second one dollars per unit.
Excellent. Perfect. Okay,